All right, so welcome everybody. I'm really happy that we managed to resume our programming principles series. It's been some time. I checked and it was autumn 2001. So it's more like a year and a half since my last talk. But I'm hopeful that we can resume this and continue going forward, as there are many more topics that I have on my list that I think that they're worth sharing. So today I'm going to talk about currying and partially applied functions. So again, it's a topic coming from a functional programming world, but it's also applicable to object-oriented programming. Okay, so let's talk about functions first. I wanted to just describe two basic terms when we have a function. And one is the arity. It's the number of arguments or operands taken by a function. So when you have a normal function, it can take number of arguments. So if we have a nullary function, or arity is nullary, then the function doesn't accept any argument. With unary, it's like single argument, binary is 2, and variadic functions take a variable number of arguments. So this is arity, and which is not to be confused with type cardinality. So type cardinality means how many values are there in the type, it's the number of values constrained by the type. I would start with TypeScript and Java void keyword. It might be not super intuitive, but this is actually cardinality 1. It means that if a function returns a void, it doesn't mean that it doesn't return anything. There's actually an information, which is like a single information that the function can return, which is not the same thing as we have in Scala Kotlin. We have a type nothing. Or if you're coming from a TypeScript world, there's a never keyword, and Rust has this exclamation mark, and they're all describing a type that has no values. So if we have a function that returns never, it means it doesn't return. It doesn't return at all. So the only way for the function to give back some information to the caller is by throwing in an exception. And also nothing is a type used. It's like a type that inherits from all the other types. So it's like on the opposite side of the hierarchy, when on the top we have, like in Java, object, like all objects in Java inherit from object. So nothing or never is at the bottom of the hierarchy. So it basically inherits from anything. And using variance and contravariance, we can, for example, assign a list of nothing to a list of anything, basically. So going back to cardinality 1 in Scala and Rust, we have something which is called a unit, which is like more expressive. It more describes the thing that it's the one value that is returned, the unit. Kotlin has a unit keyword. And for example, cardinality 2 of a type is a Boolean. So I can return false and true and nothing else. So we have like 2 values encoded in that type. Or if we have, for example, an enum with 2 items. So with cardinality more than 3, it's like the example is integer numbers. So depending on the width of the integer, like for example 4 bytes, we can have as many as like 2 squared, or how do you call it, 32, or ADTs, like products of these not infinite cardinality types. And cardinality infinite is, for example, for strings. Like this is like theoretical, there's a limit, of course, by the amount of memory you can allocate and so on. But in theory, strings, there are as many strings as you can think of. So, and also a function, so, or extensible type. So if I'm returning some type or a class from a function that is extensible, there can be infinite number of types that inherit from the type. And same applies to function. So if we have a function signature, which is like an interface for function, there can be infinite number of implementations for that function. So we're going to mostly focus on the arity here when we're going to talk about currying and curried functions. So just to recap what's higher order functions. So here we have a single function which takes two arguments, one of type A, the other of type B, and returns a value of type C. So this is like a normal function. Here we have a higher order function. It's a function that accepts a value of type A and returns a function. So by higher order functions, we mean that it's a function that can take or return a function. So here's the example with the function accepting a function and returning a value of type C. This is pretty common. Like if you have a list or array and you're using map on that array, and the map function accepts a function and transforms all of the elements of the array, returns the array with all of the elements transformed. So this is the higher order function that accepts a function as a parameter. Now we're going to focus on that kind of on that kind of functions. The second one. So curried functions. It's not about cooking. It's about like making functions accept arguments y-bound 1. It's named after a logician, Haskell Curry. And if you're wondering that if Haskell programming language is named after Haskell Curry, then yes, it is. And not only that, I learned that there are two more languages named after Haskell Curry, because he had a middle name also, which I forgot, but there's a programming language named after his middle name as well. So he must have been a really prominent figure. All right, so what's curried function? It's a function that accepts one argument and returns another function that accepts the next argument. And the currying is the technique of converting a function that takes multiple arguments into a sequence of functions that each take a single argument. So here's the example. We have a function that takes A and B, returns a C. Now, this can be rewritten into a function that takes A and returns a function that takes B and returns C. So here's the example. This is like a pseudocode, not specific syntax to any language. So if we have a function add, a simple addition, takes A and B as numbers and returns A plus B. This is like the first example here. Now, this can be implemented as a function add that takes one argument and returns a function, which takes B and returns A plus B. And we call it like that. So we call it not as with all the arguments provided, but we call the first function first, which returns a function, and then we call the second function. So this is basically an act of currying a function. Now, this is a bit different to partially applied function, but it's conceptually the same. The only difference is that partially applied functions allows to apply multiple arguments and return function that takes the rest of the arguments. So if we had like 3 arguments here, A, B, C, we can apply 2, and that would leave only the third C argument, which would be accepted by the function that is returned here. right? So it's like a more general way of how to apply a subset of arguments to a function. And there's another concept called partial function. So I wanted to highlight that distinction, that partially applied function and partial function is different. And partial function relates to implementation of the function, that it might not be applicable to all of the values of the type that it's provided for the function. So the partial function is applicable to just a subset of values that are expressed by the type. So for example, divide partial function is applied for all of the integers except 0, right? So this is a partial function. Okay, so let's go on a tour and we'll go over some of the languages and how they support currying and curried functions. So let's start with Typescript. So here we have add function. It's normal, like nothing special. It's arrow function. Could be as well implemented via function keyword, but I'm going to use like arrow functions. So if you want like automatic conversion of a function to carried version, we could use some library like Lodash. Or I think Ramda supports this as well. So I would use carry function provided with the function, and I would get back carried version. And that carried version can be applied argument by argument. And this is like a manual version of that add function, add carried manual, and it looks like that. So this is the syntax. I'm taking a number and I'm returning a function which accepts another number and returns a number. And this is the implementation. And it's called in a similar fashion as the one automatically created by the carry function in Lodash. Kotlin here, this is the function definition with the implementation for add. So this is like a manual version of the carried function. I'm providing an A and I'm returning a function that takes a B and returns A plus B. And it's used similarly, just applying first argument, applying second argument, I get the result back. If we want an automatic carried function, we could use arrow. It's like a functional library for Kotlin. And it returns back a carried version of the function. Here's Rust. What's interesting here we have like manually carried version. This is the normal version of the function. And if we want automatically carried function, we can use the carry library, carry RS. So it's a package from Rust ecosystem. But interesting here is that it's macro, which means that it's expanding that add function on compile time. So while the compiler compiles the code, it would produce carried version of the add function here. So it's not like in runtime, like I showed in TypeScript or Kotlin. Elm, which is heavily inspired by Haskell. What's interesting here is that all functions are by default carried versions. So this is basically the standard way how you would write functions in Elm or Haskell. There are a couple more like Unison. So all of the functions are carried versions. And if you don't want that, you would just use a tuple, like a structure as an input argument. Java, this is quite interesting. So Java, this is syntax for arrow functions in Java, but the types here, the types are fully typed, this implementation is basically this type. So we have a function that takes an integer and returns a function that takes an integer and returns an integer again. So this is like a manual version of the curried add. And if we wanted the automatic curried version of a function, we could use again functional library behaviour. And what's interesting here is that this function here is like a normal Java function, but it's assigned to the interface from behaviour library function 2. And how come we have curried method on that interface if it's like a normal function? If you know later Java features, so there's a like default implementation in interfaces. So this curried method here is like default implementation in function 2. And if we want to apply an argument to it, we would need to call apply method. So it doesn't support directly with those brackets applying an argument. So let's see what we can do in Scala. So Scala supports carrying out of the box. You don't need any libraries. You just have like normal function or method. Def is a method. All you need to do is not to provide a second argument or any of the arguments that you want to leave as input parameters for the return function, right? So it's like a language feature right there. And it's also called, if we're partially applying a method, it's called eta-expansion. So this was like a tour of languages. Now let's think about why the currying is needed, or why do we have it? Is it needed at all? What are the use cases or applications? So first is like builders. So if you have a record or a case class or whatever, you have a class with a constructor that takes a number of arguments or parameters. There's actually a difference between parameter and argument, which parameter is like on the definition, argument is on runtime, it's like provided, just to be clear, but I use it like interchangeably. So I can provide like first argument, and then I can do some computations, provide second argument, do some computations, pass it over, and provide a third argument, so I can have a builder in form of curried function. Or some more like real or more used use cases with event handlers. I'll show an example for that one, or convenience. So if I have a function that takes number of arguments and I always repeat the first argument, I can as well apply that once and then just apply all the rest arguments if they are different. And caching, I have an example for that, but this is like a special thing. So here's the example for event handlers. So we have some kind of a JSX syntax here, like in React, for example. And what we do here is we have a list of statuses and a function set send update, which sends an update for a specific service. Here just prints to the console. And we have a picker. So I select an option like online degraded offline. And when I select it, I should update the server about the state of this service. Now on select is itself a higher order function that takes a function. So this is a lambda syntax. So S is like the selected value, and I can do something with it. So I would call the send update function with the service A and S as a selected status. For service B, same thing. Now I can rewrite this. So I would carry that send update. So instead of taking two parameters, I would take one parameter and then return a function that takes second parameter, right? So, and it would basically call the first and update. What's nice here is that I can provide right away the result from calling send update to the event handler, right? Because it's a function. So it's kind of, it's obscure in a way that it doesn't really show what we are consuming, but it's convenient if you know what you're doing, that it actually applies the selected status to that function. All right, and here's a special example. So this is in Scala, and we have two functions: find in file v1 and find in file v2. Now they have the same signature, so it's a function that takes a file, returns a function that takes a string, and returns a Boolean. Here's the same thing. What's different is the implementation a bit. The first one prints loading file and loads the file. So we are basically, what we want to do is to find the text in a file, in a text file, right? So we load the file. We load all the lines and put it into the string. And then we're searching the string against the text that we want to search, right? So ignore that the file is not closed and so on. Sorry. So now here we would load the file, make the text from that file, and just use the contains method on the string. In the second case, we would, again, same line, we would load the file, put it into the text, into file text string, but instead we would return function. So the signature is the same. However, the implications are pretty important. So if we, for example, wanted to search the Scratch file, so we would find in file v1, we would provide that file, Scratch file, and now we want to search in that file. So what do you think that how many times we would be loading that file in the v1 and the v2? And the answer is here, we would load it twice. And in the second one, we would load it only once. And the difference is here that in that scenario, we're returning a function that closes over that file, and it would need, every time I'm calling the second returned function, I'm actually executing the body of the function, the whole body. In the second case, I'm returning a function which already closes over the file text which is loaded. So when calling it multiple times, the file is already loaded, so it works like a cache. Now I just wanted to highlight that whether that's currying or not, it doesn't say anything about how it's the same result that we have like a higher order function, but the implementation is different. And now I think that the currying doesn't tell anything about how the implementation of the transformation is done. So whether that's currying or not, I'm not sure. Like, it's questionable and open to interpretation. All right, and I guess that's all from me. So now I'm open to questions if there are any. I hope it wasn't too confusing. I used the word function like a million times. So.
In the example that we had with the file, would that mean that the curried function occupies as much space as the loaded file with all the data? even though it's not called. I guess this.
Yes, that's correct. It's like a closure. So if you have a function that takes a variable from outside of its context, like here, this text arrow file text, this is body of the function. Like this is the parameter, and this is body of the function. So we're taking the file text from outside of the context of the function. So it's basically a closure. It closes over the file text. So while the function lives, the file text is not eligible for collection, right? For garbage collection. So yeah, it would occupy the memory. Does that answer your question?
Mm-hmm.
Maybe.
Yeah, and in case you would like to reload the file, you would create another function, and the previous one would have to be freed up.
Yeah. But also, like a garbage collection mechanics would still apply. So if that function is no longer used, it's out of scope, like you're out of the stack frame and it's no longer used anywhere in the reference. So then it can be collected, and then the text, the string, memory can be collected as well. Okay, any more questions?
I have a question.
Okay.
And if you compare this one with opposite to the or contra object with single function, what is the difference?
It's the same thing, like an object with single function. Well, basically, the function itself, like a literal, is compiled to the object with single method, right? So if you look at Java, for example, it's a function interface with apply method. So just a syntactic sugar.
Yes, but just I understand. Just thinking like you will probably need some like additional function. Like now you have there something like the contents, and probably you will want to add some additional functionality like check the header of the file. Then you are creating the object after that.
Yes. Well, I'm not sure I understand the question.
I'm just trying to figure out what is the difference between this one and the pure object.
I don't think that on runtime there's any difference. If it compiles to the object, it's the same thing.
Yeah. Thank you.
Maybe there are some optimizations, I'm not sure. Okay, any more questions? Feel free to ask. All right, if not, then reach out to me anytime. I'm on Slack. If you think of anything that's not clear or you wanted to elaborate on. So, yeah. Okay, cool. So thank you very much, everybody, for your attention.
Thank you so much.
Next time.
Thank you.
Bye.
Bye-bye.